We are now looking at Chapter 4, Rational Expressions and Equations. Chapter 4 is Unit 2. But before we begin to look at the material in Chapter 4, we're going to review factoring a binomial, since this is a prerequisite for Chapter 4. You must know how to factor a binomial. So in this lesson, we will look at factoring various types of binomials that you will encounter in this unit. Recall that a binomial is a polynomial expression with two terms. For example, 2x squared plus 6 is a binomial, since there are two terms, 2x squared plus 6. There are two types of binomials that you're required to know how to factor for this course. The difference of two perfect squares, and recall that difference means subtraction, and the greatest common factor. You may have to extract greatest common factor. So in looking at this difference of two perfect squares, you can identify this binomial because the first term will be a complete perfect square, the second term will be a perfect square, and there will be a difference. And we factor these, we still get the product of two binomials. We factor these to the square root of the first term, square root of the first term, and the square root of the second term, square root of the second term, and then add and a subtract. Let's look at the next example. Once again, we know this is a difference of two perfect squares, since 9x squared is a perfect square and 25 is a perfect square. And there's a difference separating them. That will give us, start with our brackets, the product will be two binomials, 3x and 3x, 5 and 5, plus and a minus, or a minus and a plus. The last one we have x squared. We have x squared and 1. Subtract 1. We see that that's going to be x squared is a perfect square and 1 is a perfect square. X plus 1, x subtract 1. We can look over and see there's the greatest common factor. This is a binomial, yet it's not a difference of two perfect squares. 3x is not a perfect square, nor is 12 a perfect square. What we must do is look for a common factor. The common factor between 3x and 12 would be 3. So 3 would come outside, and we would have x subtract 4. We can verify this is true, since 3 times x is 3x, and 3 times 4 is 12. So look at the next one. We have 4x squared plus 8x. So we have a common factor of 4x, x plus 2. We can verify that this is true because 4x times x is x squared, and 4x times 2 is 8x. We have a look at the next one. We have a binomial. We have x squared subtract x. Therefore, x would be the common factor. Left inside the bracket will be x subtract 1. Let's look at an example. You may want to pause the video, or the clip, sorry, and attempt this one. This is a difference of two perfect squares. X and x, 6 and 6, plus and a minus. Sorry, plus and a minus. Should be a minus. Let's verify that it's correct. I could check it to make sure I am correct in doing this by multiplying two binomials. You may have multiplied two binomials by using the FOIL method or the box method. And we see x multiplied by x is x squared. X times a positive 6 is plus 6x. Then we have minus 6x subtract 36. So we see that these can cancel. It gives us x squared subtract 36, which is what we started with. So we were correct in factoring that binomial. Let's have a look at the next one. There is a common factor here of 3x. What is left inside is 6x squared divided by 3x will be 2x subtract 1. Since 3x divided by 3x would give us 1. Now this one poses a little bit of issue here. It's a concern. It is a difference of two perfect squares, yet there is a common factor. And the common factor overrules. You have to take out the common factor first. So the common factor is 9. We'll take that outside. We're left with x squared subtract 4. What is left over is a difference of two perfect squares, so it's not factored completely yet by just leaving it like this. We'll have to go 9, x plus 2, and x subtract 2. So be aware that even though it looks like a difference of two perfect squares, and there is a common factor, you must take out the common factor first. You will be required to factor binomials in order to simplify the rational expressions in this unit and determine the non-permissible values. Be able to distinguish between a binomial that is a difference of two perfect squares, example, x squared subtract 81, and a binomial that requires extracting a common factor, something like 5x squared subtract 15.